So this question is referencing one of the core practicals that we have completed, and it's all about neutralization. So if you have a look at the steps, they're adding the hydrochloric acid into a beaker, then they're adding powdered calcium carbonate in small amounts each time. And it asks you, before they take the pH, what should they do in order to check the reaction is complete? So the calcium carbonate, calcium hydroxide, you need to make sure it's reacted. So what you would do is you would stir the reaction, and that way you are encouraging it all to react, or as much as possible it needs to react. Complete the word equation. So hopefully you remember where we have acid plus base makes a salt, and it makes water in there as well. So in this situation, the salt, because it's hydrochloric acid, the salt is going to be called calcium chloride, and we will then have water, and you get 1 mark for each of those two products. State symbols, which one shows the correct state symbol? So here's a clue. This is powdered, so that means the calcium hydroxide is solid, and dilute hydrochloric acid, this means this is dissolved in water. If it's in water, it is a solution which is aqueous. So I'm looking for something that is solid for the calcium hydroxide and aqueous, and the only option we've got is option C that matches the answer we've got. Okay, here is a pH curve. Remember, they always start, where we have starting with an acid, they always take this shape, showing that the pH very steadily, but over a long period of time increases. Then there's a rapid change in pH, and then it levels off and again stays level for a period of time. So it says, use figure 4 to give the pH at the start of the experiment. So if we just zoom in here for a second, I can see that each of these, this is going to be halfway, so that's going to be a value of 1. So we've got a pH here of 1. So let's drop that in. So pH is 1. Give the mass to make the mixture neutral. Okay, so I know that pH 7 is neutral. So what I'm going to do here is go into the middle between 6 and 8. That's where 7 is. And I'm going to take that line to where it meets the graph. And then I'm going to bring that line down that way. And I can see here that that is 0.7, so that's 0.72 and then 0.74. So my answer to this question is 0.74 from the graph. Explain why the pH starts off low. So at the beginning, the pH is acidic, and that is because it contains hydrogen ions. Remember, hydrogen ions are what makes something acidic. So it contains hydrogen ions. Then as the reaction goes on, the concentration of hydrogen ions is reduced because they're going to react as they react with the hydroxide ions. So that neutralizes it. We've got at pH 7, H plus ions from the acid are equal to OH minus ions from the hydroxide. So we've got that fact in there. And then as the pH increases above pH 7, there are more OH minus ions. So we get a change in that. The marks for that, you're going to get a mark in here for saying this is why it's gone on, this is why it's reducing towards neutral, and this is why the pH continues to rise above that point.